video, I'm going to talk about graphs of sine and cosine. Before we talked about going from the equation to getting the graph, and in this video, I'm going to talk about how to go from the graph to the equation. So we're going to talk about writing equations from graphs. And there are certain things from the graph that we want to identify. The first thing that we want to identify is it easier to use sine or cosine? Even though both could work for every graph, which one is easier to use? So identify which one is easier. Sine or cosine. The next thing we want to identify from the graph, probably the easiest thing to identify, is what the amplitude is. So we want to find what the amplitude of the graph is, and we know that goes in our equation as the coefficient for sine or cosine. The other thing that we talked about that we can get from the equation is the period, so the horizontal length of one cycle of the graph. And we know that we can use that to find what b is. So we're going to use the period to find what b is equal to. The next thing that we're going to look for is if we have a horizontal shift or a vertical shift. So if there's a horizontal shift or if there's a vertical shift. And the last thing we check for is to see if the graph is flipped upside down, if there's a reflection over the x-axis. So we look to see if there's a reflection over the x-axis. Okay. And I'm going to draw a graph. We're going to do an example. So we're going to look at an example of a graph. And then, oopsies. And then we'll look for all of this information that we need to identify. If I count by pi over 2 for the horizontal part, so my scale is pi over 2, and I'm counting by pi over 2. I have pi over 2 pi, 3 pi over 2, this is 2 pi, and then this would be 5 pi over 2. Over here would be negative pi over 2. I have a point, on the y-axis, I'm going to count by, I'm going to make this a little bit longer down here, and I'm going to count by, this is 1, this is 2, this is -1, -2, and then I'm going to place points. So I have a point at 0, -2, I have a point at pi over 2, 0, I have a point at pi, 2, I have a point at 3 pi over 2, 0. I have a point at 2 pi, -2, and 5 pi over 2 and 0. Also negative pi over 2 and 0. And then I connect these. Whoopsie. I connect these. And this is the graph that I'm starting out with. And I want to find all of this important information. The first thing that I want to decide is it easier for me to use cosine or sine to write an equation for this? And what I really want to look for, is either a C shape or an S shape starting at 0. So I'm going to look from 0 to the right. I'm going to look for one full cycle. And I see this is one full cycle, and it's a C shape, so starting at 0, cosine would be the easiest one for me to use. So I'm going to write a cosine equation for this graph, because the first thing that I see to the right of 0 is a C shape, one cycle for cosine. So I'm going to use cosine equation. I know that the amplitude for this thing is from the middle to the top, so the middle is at y is equal to 0, and the top is, the maximum is 2. I know the amplitude then is 2. So the amplitude is 2. The period is the next thing that I'm looking for. So I know that the period is 1 full cycle. What I highlighted in yellow is from 0 to 2 pi. So I know that 1 period is 2 pi. And I know that a period is 2 pi over b. So I need to solve for b. That's what goes in my equation. I have 2 pi over b is equal to 2 pi. That's 2 pi is equal to 2 pi times b. I divide both sides by 2 pi. And I get that b is equal to 1. So b is equal to 1. That's going in my equation. The next thing I look for, so I took care of amplitude. Oopsies. I took care of amplitude. I decided if cosine or sine was easier. I found the b from the period, and then I'm looking for if there's a horizontal shift. I'm starting at, the reason why I picked cosine was because I was starting at the y-axis. There was no horizontal shift before I got that C shape, so I don't have to do that. The vertical shift, there is no vertical shift from the parent function. The parent function is at the center is at y is equal to 0. The center here is at y is equal to 0, so I took care of that. And then I want to look if there's a reflection over the x-axis. That means, is it upside down of what it would be in the parent function, that shape? Well, in the parent function, that shape looks like this. It's a U shape. But this I see is upside down. So I do know that there is a reflection over the x-axis, and that means that there is a negative coefficient. So I know there's a negative coefficient. Oops. And now I'm going to write my equation because I went through all of these things. The base for the equation is y is equal to a times, this is cosine, so a times cosine of bx. And then I plug in the information that I have. So I have y is equal to the reflection over the x-axis. That's gives me a negative coefficient. I know a is 1. Sorry, a is 2. So I put a 2 for a. I have cosine b is 1, so I don't need to write it, of x. And there's no vertical or horizontal shift, so this is it. And that's my equation for cosine. I can write an infinite amount of equations for this graph. There are infinite equations that work for this graph. I'm going to write a sine equation as well, and see what a sine, one example of a sine equation would look like from this graph. So I'm going to highlight the first S shape that I see to the right of the x-axis. So this is the first S shape that I see. First thing I know is that the amplitude is still 2. So the amplitude from the middle to the top is still 2. And that hasn't changed, and it will never change. It will always be the same for sine and cosine, the amplitude, since it's the middle to the top or the middle to the bottom. And even though the maximum and minimums change a little bit, they're still going to be the same. Like, they change where they are as horizontally. They're still vertically going to be the same. And the center is still going to be the same. So I also know that the period is 2 pi. If I go from pi over 2 to 5 pi over 2, that's 1 cycle. I know that that is 2 pi. So b is equal to 1. We already solved for that, so I don't need to do it again. And then I'm looking, so I did amplitude, I did period, horizontal shift. Is there a horizontal shift? To what I highlighted in black, there is a horizontal shift. It doesn't start at 0, 0. The horizontal shift is right at pi over 2. So it's right pi over 2. And then vertical shift, again, it's the center is at y is equal to 0. There is no vertical shift. And that is the shape in the parent function going up and then down. So I know that there is no reflection over the x-axis. So I start my equation. My base is y is equal to a times sine of bx, because this is a sine equation that I'm writing. And I just fill in what I know. A is 2, so I put a 2 here. I have sine of bx. B is 1. X, I know there is a horizontal shift, so this is a horizontal shift. And I know that that means that I have something that's happening inside with x, inside of the function. And I know when I'm moving right, I am subtracting, so subtracting pi over 2. Whoops. Close that with black. And there's no vertical shift. This is my sine equation for that graph, or just one example. For another example, so example 2, I have a graph. Oopsie. I have a graph that the scale again is pi over 2 by pi over 2. So I have pi over 2 pi, 3 pi over 2, 2 pi, 5 pi over 2. This is negative pi over 2. And then my scale on the y-axis, I'll do this is 2, this is 4, negative 2, negative 4, and then I'm going to plot some points. I have a point at 0 and 1.5. I have a point at pi over 2 and 4. I have a point at pi and 1.5. I have a point at 3 pi over 2 and negative 1. I have a point at 2 pi and 1.5, and 5 pi over 2 and 4. And then at negative pi over 2, I'm at negative 1. And then I'm just going to connect these. Oops. And they're supposed to be curvier, but whatever. And then I'm going to look at all the things that I have here. So the first thing I want to look for is, what is this? The first thing I really want to look for here is what's the center of my graph, so I can tell what's happening more easily. The center of my graph is the points in the middle. So where the points in the middle are at the horizontal line that goes through those points in the middle. So I'm just going to draw that in. And I know that I just told you, but those points are where y is 1.5. So my center is y is 1.5. That means I have a vertical shift here. And I'm treating that blue line as my new x-axis, like we did in the last lesson. And I'm looking for what's the first shape that I see here. So starting at 0, I look at 0 and I'm looking for either an S or a C, and then I'll stop up. I made an S shape. Since I made an S shape, I know that this is a sine function graph. And so I am going to write a sine equation for this. I'm going to write a sine equation. And the sine equation, I know, the first thing I'm looking for is amplitude. The amplitude from that middle that I drew to the top is 2.5. From the middle to the bottom, 2.5. So amplitude is 2.5 here. You could always find that by subtracting 4 minus 1.5, which gives me 2.5. Or I could do 1.5 minus negative 1 to find the difference, which would be 2.5. And then that's the amplitude. Then I'm looking for what is the b. So I need to find what's the period. So first of all, the period is 2 pi again. And we already solved that, so I'm not going to do it again. Then that means b is equal to 1. I need to get b. I do not put 2 pi into my equation. I need to know what b is. B is the coefficient for what's inside of sine. Or cosine. Sine in this case. Then I'm looking for, what's the next thing? Horizontal shift. So let's see if I have a horizontal shift. Not for sine, because I start at 0. I start that S shape at 0, so I don't have a horizontal shift, but do I have a vertical shift? Yes, I do. I have a vertical shift because the parent is at y is equal to 0 as the center. This center is at y is equal to 1.5, so I am moving up 1.5. That is not a reflection of the x-axis. So this is the shape that I would have in the parent function going up and then down. So I can start writing my equation now because I've gone through all of those things I need to identify. I have y is equal to a times sine of bx. And then I'm going to plug in what I know. So I know a is 2.5. I have sine of 1 I don't need to put. So I have sine of x, and then I'm adding 1.5 at the end because I moved up 1.5, and this is my equation. I can also write a cosine equation. I'm going to do that. Write a cosine equation. I know that the amplitude is the same. A is 2.5. That's the same. I'm going to highlight this. So to the right, the first U shape that I see is here. That's the first U shape that I see. And I know that that shape from pi over 2 to 5 pi over 2, that's a distance of a horizontal distance of 2 pi, which means that b is equal to 1 again. I know that I do actually have a vertical shift to get to that start of that U shape. I move to the right from the y-axis, plus 2, so to the right, pi over 2. Sorry, not plus 2, plus pi over 2. So I'm moving right, pi over 2. And then I know that I have a vertical shift. The new center is at 1.5, so I moved up 1.5. And this is the shape. This is the shape in the parent function. And it's not upside down, so I don't have a reflection over the x-axis, so I can start writing my equation. Y is equal to a times cosine bx. And then in this case, my a is 2.5. Oops, I have cosine, b is 1, so I don't need to do anything with it. I do have a horizontal shift, so I'm going to put this in parentheses. X to the right, pi over 2 means I'm subtracting pi over 2 inside. I'm subtracting it from x inside of the function. And then I have that on the outside plus 1.5 because I'm moving up 1.5. And this would be my equation for cosine. And I'm going to do one more example that's a little bit harder. So I have this example here. I'm going to draw this graph. I'm counting by pi this time. So pi, 2 pi, 3 pi, 4 pi, 5 pi on the x-axis. This is negative pi. I have 1 here. I'm going to do 2 here. And negative 1 here. You know what? I'm just going to make this smaller. I'm going to do 1 here and 2 here. Negative 1 and negative 2. And then I'm going to plot some points. So I have a point at 0, 0. I have a point at pi and 1, pi comma 1. I have 2 pi and 2. I have 3 pi and 1, 4 pi and 0, and then 5 pi and 1, negative pi and 1, and then I'm going to connect all of these. So, oops, this is what my graph that doesn't look good. That doesn't look good either. This is what my graph looks like. And then I want to decide if cosine or sine is better for me to use here. So I have, I'm looking at 0. If the first shape that I see is C shape or a S shape, and it's a C shape. So I know that it's best for me to use, because it's a C shape, to use cosine. So I'm going to write a cosine equation. I need to write cosine. Or I'm not going to fit everything. So I'm going to write a cosine equation first. That's going to be the easiest. So even though there's infinite amount of equations you can write, you want to find the one that's the easiest with the least happening, the least shifts, and things going on. So this is my, it's going to be cosine. What I want to do is I want to find the center of my graph. The center of my graph I know is in the middle, so through these middle points, and that is this line here at y is equal to 1. So I'm going to treat the new x-axis as y is equal to 1. That's the center. Then I know the amplitude from the middle to the top is 1, so a is equal to 1. That's the amplitude. I want to find what b is, so I'm going to use the period. The period, I know in this case, one thing I highlighted, one cycle that I highlighted in yellow is 4 pi. I know that period is 2 pi over b, so I want to solve for what b is. That's what goes into the equation. I'll get 2 pi is equal to 4 pi times b. I'm going to divide both sides by 4 pi. And I'm going to get that b is equal to 1/2. So b is 1/2. I also know that I'm looking if there's a horizontal shift next. There is none because I started that yellow shape. That's why I chose cosine, is because it started at 0, so there was no shift. But I do know that there was a vertical shift. So the center moved from y is equal to 0 to y is equal to 1. So I know I went up 1. All my points went up 1. And then I do know that this is upside down. The parent function for cosine looks like this shape. That's what's repeating over and over to the right-hand side of 0. Or the y-axis, and what I'm seeing is upside down. So I know that there is a reflection over the x-axis, which means there's a negative coefficient. Now that I've looked at everything I'm supposed to look at, I'm going to use y is equal to a times cosine b of x as a foundation, and then I'm going to plug in the things that I know. So I have y is equal to a is 1. I don't need to write 1. So I'm just going to write cosine. B is 1/2, so I'm going to write 1/2 times, there is no horizontal shift, so it's just 1/2 times x. And then I know I'm going up 1, so I'm going to add 1. And also there's a reflection over the x-axis, so I need to have a negative in front. And this is there's a +1 at the end because that means I move up 1. And so this is my cosine equation. I can also write a sine equation for this graph. So let's see what that will look like. I know a is still 1. B is still 1/2. Whoops. I know I'm still moving up 1, but first I want to look at my horizontal shift. So I'm going to highlight the first S shape that I see, and here's the first S shape that I see. I moved from the y-axis over pi, so pi to the right, so I went right pi. That was my horizontal shift. And then I also went up 1 for all of my points. I went up 1. And then I have, it's not a reflection over the x-axis because this is the shape starting at 0, 0, that my parent function has for sine. And that's the shape that I see there. And so I can start writing my equation. So I have the foundation is y is equal to a times sine bx. And I know that I'm plugging in 1 for a, which I don't have to write because it's not going to change the function. So I just write sine of 1/2 times. Now there is a horizontal shift here, so I have to put in parentheses x minus pi. And then I add 1 on the outside. So I shouldn't have written this as sine of 1/2 x minus pi. That's not how I should write it. The 1/2 has to go to the x and to the minus pi. So if I do write it like that, I have to include the 1/2 in front of the x as well. But it's best to write it this way, easiest to write it this way with the 1/2 as a coefficient and everything else in parentheses. And this is my equation if I use sine.